right, here we go. Savings annuity time, continuing in finance. So we've been working on these type of equations that have all of these different items, working on putting them in the calculator, and now we know what they are. It's a savings annuity. So a savings annuity is something where you make multiple deposits. So it's different from a compound interest or a simple interest because it is compounded. We're still going to have compounding units in a year, but it's a regular deposit. Think of your saving for an IRA, a retirement account, something like that. So PN is the balance at the end, PN end. D is that regular deposit amount. R is the annual rate in decimal form. K is number of compounding periods in a year. And then N is the number of years. So it's great for saving over time. You don't have to memorize these either. So for this problem, we're going to round to the hundreds because now it's money. And we've got the equation here, and we're going to identify the variables. Whatever we don't have is what we need to solve for. So we are depositing 300 into account earning 8% compounded monthly. Monthly is 12 months in a year. And we are saving for 15 years. So we don't have PN. How much will you have? So PN equals D 1 plus R K to the NK. And I've got to have these extra parentheses here or it'll mess it up. To the RK. So we've really been focusing on how to put this in the calculator. And that's what we're going to do here as well. So I'm going to use mine. I'm putting it in exactly how you see it with all of those parentheses. Don't forget that -1. And if I do that savings plan, I will end up with a nice amount at the end. So again, how I typed it in was I truly put in exactly how the formula had it, every set of parentheses, but I put an extra one at that N times K. So after 15 years of saving, we'll have 103,811.47 cents. Awesome. All right, formula is still here. We want to have 850,000 when we retire. So that's our P of N. We've set this retirement goal. We're retiring in 25 years. How much do I need to invest each quarter? And my rate is 0.043. Quarterly is 4 for 12. I'm sorry, not. Or for K. Okay. So it's going to be 850,000. Pull D out. 1 plus 0.043 divided by 4 to the NK -1 divided by 0.043 divided by 4, and then I'm going to divide that number in. So I can actually do it all at once if I want to. And then I'm going to put an extra set for the bracket. So 1, 2, 3. 1 plus 0.043 divided by 4. 25 times 4 -1. Remember the bracket's not yet. That went haywire. That was not right. Let's go do it over on Desmos, which might be what more of you guys are going to have. Okay, so I tried to type it all in at once, and I think I messed up my parentheses. So I've got 850,000 equals D. Okay, then I've got this top part, 1 plus 0.043 divided by 4 to the 25 times 4 minus 1. 1, 2, 1, 2. Okay. And then divided by 0.043 divided by 4, close the bracket. Let's try this again. See if I can show it to you. Now, the way I knew that wasn't right was that was way too small to invest quarterly to get $850,000. And I like Desmos because it was telling me you should have another set of parentheses. So it was helping me figure that out too. See, it keeps it kind of in that gray. All right, so that's the answer I get. So I'm going to do 8.5 divided by that whole answer. Much better. Now we're getting it. There we go. That is what we need to be putting in quarterly. It's got to be a significant amount to get to that 850,000. So again, I've got my Desmos up. Look at how I typed it and make sure you've got it. And I have run out of room. So it was 4, gosh, hold on. It was 4,775. $95 per quarter. So that's every 3 months how much you need to be putting in to get to that 850,000 when you retire. All right, last one. We deposit 100 a month into an account, earning 3% monthly. How much will we have in the account after 25 years? So I've got the D, I've got the R, I've got my K, and I've got my N. I need my PN. All right. So you would want to type that in. And that should give you 44,678. From there, how much money did you put into the account? Well, you put in 100 every month for 25 years. You know, is this a good deal? You put in 100 times 12 times 25. 30,000. That's a pretty good deal. So interest is going to be the difference. So 4460.78. So it's the difference in the two amounts. So you made a pretty decent chunk of interest here, almost half of the original investment in interest. All right, that concludes our savings annuities.